Hello all, welcome to Gurukul Cat 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 48 of 100 Days to Cat Quant series. In this video, we'll be discussing 5 questions from PNC and probability. So whenever you come across a question on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions in the form of a test, you can log into our portal, the gurukul.org.in. Right, once you sign up, you'll find a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD, and VRC. We will be uploading 100 tests in each section. So if you're a serious CAT 2025 aspirant, you cannot afford missing this. So without any further delay, let's get started with the first question. Now coming to the first question. In a certain entrance test, there are 10 questions and each question has 2 parts, A and B. A student may choose to answer a question by attempting at least one of its parts, right? That is either part A or part B or both. Find the total number of ways in which a student can attempt one or more questions in the paper. So you should be having a student attempting at least one question in the paper, right? Now let's try solving this question in the easiest possible way. Now in order to do that, I want you guys to understand that for every question, you can have student attempting only part A or only part B, both the parts A and B, and none of them. So for any question, student will have 4 choices, right? Attempting only part A or only part B, attempting both the parts, or not attempting any of them and leaving that question. So we have 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now coming to question number 1, student has 4 choices, right? 4 into, coming to question number 2, again 4 choices. Question number 3, 4 choices. So on till question number 10, 4 choices. So there will be 4 power 10 possibilities, out of which there is only one case where a student is not attempting any of these 10 questions, not attempting question 1, not attempting question 2, so until question 10. So we need to subtract that one case. So 4 power 10 minus 1 should be the answer to this question. Now coming to the second question. Arjun is distributing chocolates. In how many ways can he distribute 15 identical chocolates among 4 employees, Rahul, Sneha, Kabir and Tara, such that only Sneha and Tara are guaranteed to receive at least one chocolate? Right, so we have 4 persons: Rahul, Sneha, Kabir and Tara. And there is a condition that Sneha and Tara are guaranteed to receive at least one chocolate. So let us first satisfy that condition, Sneha and Tara. So let us assume that Arjun has already given one chocolate to both Sneha and Tara. So Arjun has a total of 15 identical chocolates. Now after giving 2 chocolates to Sneha and Tara, he will be left with 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now he has to distribute these 13 chocolates among these 4 people. Right, now the given condition is also satisfied. Now we need to divide these 13 chocolates to 4 parts. Right, now let us imagine that you have 13 chocolates lying on the floor and you want to divide these 13 chocolates into 4 parts using sticks. So how many sticks should be placed? Now if I place, for example, one stick here, you have 2 parts. Second stick, you have 2 parts, sorry, 3 parts. And if I place third stick, you have 4 parts, right? So I can divide these 13 chocolates, right, into 4 parts by placing 3 sticks, right? Now these 13 chocolates are identical, these 3 sticks are also identical. Now let us find the total number of ways in which we can arrange them, right? So you have 13 chocolates plus 3 sticks, so you have 16 objects in total that can be arranged in 16 factorial ways. By, out of these 16 items, 13 are chocolates, identical chocolates. So by 13 factorial into, now these 3 are 3 identical sticks, 3 factorial. So 16 factorial by 13 factorial into 3 factorial, which is nothing but 16 C3, and that should be the answer to this question. Now coming to the third question. How many three-digit numbers can be formed using the digits 0, 1, 2 if a digit can be used at most twice, right? So you cannot have same digit used thrice, right? So you can have same digit used twice, right? So first let's find the total number of three-digit numbers that can be formed. Now you can pick this digit in two ways. So this can be either one or two. Two ways into this three ways and this three ways. So in total you have 9, 9 into 2, 18. Now out of these 18 three-digit numbers, let's subtract the number of numbers where you have same digit used thrice, right? So what are those numbers? 1, 1, 1 and 2, 2, 2, right? So 18 minus 2, 16. Option A should be the answer to this question. Now coming to the fourth question. The number of ways of choosing a committee of 2 women and 3 men from 5 women and 6 men if Mr. A refuses to serve on the committee if Mr. B is a member and Mr. B can only serve if Miss C is the member of the committees. So we have a total of 5 women and 6 men. We need to form a committee of 2 women and 3 men, and given that A refuses to serve on the committee if B is a member. So if B is selected, then you cannot have Mr. A. And you can select B only if there is Miss C. Right? So one way of forming the committee is involving B in the committee, and the other way is B not being selected. Right? Now, let me consider B being selected. Now, if B is one among these 3 men, then you should also have Miss C, right? And you cannot have A. Now, we already have one man here, right? So, we need to select two more men, and you'll be having how many choices? Four choices, because out of six, one person is B, and you cannot select A. So, from 4 members, you need to select two into. Now we have 5 women, out of which we need to select 2 women. Already we have selected C, so you need to select only one woman, and you have four choices. So 4C1. So 4C1 is 4 into 4C2, 4 into 3 by 2. So 4 into 6, you have 24 ways if you wish to select B. Right? Now, another possibility where you do not want to involve B. Now, if B is not selected, then you can select A. So you'll be having 5 choices, right? Out of which you need to select 3. That can be done in 5C3 ways into. Right. Now coming to 2 women out of 5, there is no stipulated condition. So from 5, we need to select 2. So 5C2 into 5C3. So that would be 5 into 4 by 2 into 5 into 4 by 2, because 5C2 is same as 5C3. So this is 10 into 10, 100. So if you wish not to select B, you can form the committee in 100 ways. So we are asked to find the total number of ways. So 24 plus 100, 124 should be the answer to this question. Now coming to the last question, 4 cards are drawn at a time from a pack of 52 playing cards. Find the probability of getting all the 4 cards of the same suit. Right. So all the 4 cards should be of same suit. So how many suits do we have in a deck of cards? You have 4 suits. Right. So first let's select one out of those 4 suits. So that can be done in 4C1 ways. Okay, we have selected the suit. Then you will be having 13 cards of same suit. From those 13 cards, you need to select 4. That could be done in 13C4 by. So there will be a total of 52 cards. So from 52 you are selecting 4. So that can be done in 52C4. So 52C4 is nothing but the total number of possibilities. And 4C1 into 13C4 is the favorable outcomes. Right. So 4 into 13 into 12 into 11 into 10 by 52 into 51 into 49 into 48. Sorry, 50 into 49. So, 13 fours 52, okay, 10 fives, then 3 17s, 3 4s. So 4 into 11, 44 by, we have 17 into 5 into 49. 17 into 5 into 49, right? So we should be having 44 in the numerator. So I can eliminate these. So the answer should be either 44 by 4165 or 44 by 833. Now the units digit in the denominator should be 5. So option D can be eliminated and option C should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.